Alright, higher degree polynomials, this is section 2.2. Alright, so in the last section we talked about quadratics, which were just to the second power, polynomials to the second power. In this section we're going to be talking about higher degree polynomials. Alright, so first we're going to start off and talk about a few characteristics of polynomials. Alright, first one is that a polynomial is a continuous graph. That means it's defined in all points. Every point is defined, alright? The opposite of that would be a graph like this. So that's a break in the graph, alright? That is not continuous, so therefore it is not a polynomial function. Alright? Secondly, you'll see that polynomials are smooth. Alright, we're going to use the word smooth, like Michael Jackson, smooth criminal. Alright. The opposite of that would be like a piecewise function. Alright? Where it kind of has a point. It's got an edge, basically. It cannot have a sharp turn like that. This is not a polynomial function. It has to be continuous. And it has to be smooth. Just keep those words in mind. Alright. And when we're taking a look at polynomials, we'll be able to tell by the leading coefficient how the graph is going to look in general. Alright? First, if the leading polynomial is even, you know that the graph is going to start up and end up, or start down and end down. Alright? So you're going to either have a scenario like that, just like a parabola, or you're going to have a scenario like that. Alright? Whatever it does at the beginning, it's going to do at the end. Okay? When it's even. When it's an odd, so we'll do like an example. X to the fourth. That is even. Alright? When it's odd, it's going to do the opposite, obviously. It's either going to start down and go up, or it's going to start up and go down. Okay? Example of that. Go X to the 7th. Boom. Okay? Now, how can we tell which is going to be the case? Well, this one, we know that the leading coefficient, A, is positive, and this one, we know it's negative. And for this one, we know it's negative, and this one we know it's positive. Alright? So this is your leading coefficient. And when I'm talking about even or odd, obviously I'm talking about to what power the function is. Alright, if that's even, it's going to do the same thing both ways. And that if it's odd, it's going to do the opposite. The leading coefficient, whether it's positive or negative, tells us whether it's going to go up or down. So these are going up. These are going down. Alright, so those coefficients can help us understand what the graph will look like. Another thing we can do is find the zeros of a function. Alright, basically find the intercepts. How we do that? In this case, I'm just going to factor out negative 2x squared, which is going to give us negative 2x squared, which is going to be x squared plus minus 1. Alright, which tells me that the zeros are going to be at 0 for that one, and this actually factors out to be x plus 1 times x minus 1. So we're going to have zeros when x is 0, negative 1, and 1. Right? Negative 1 and 1. And we see that it's an even power, so it's going to go the same way both ways. And since it's negative, we know it's falling. So it must look something like this. It's got to touch those 3 zeros. It's got to fall both ways because it's even and it's negative. Alright? Basically what we're doing here is we're just understanding what the function looks like. And finding the zeros can help us. Looking at the leading coefficient can help us. And looking at the power can help us as well. Alright? And that's all we're going to talk about for now. Alright? Get more into it later. Questions? Good luck.